In the final section of what we're going to be doing, we're going to be taking a look at universal modus ponens and universal modus tollens. Sort of like a branch off of logic, but it's more geared towards the idea of working with the predicates. Universal modus ponens suggests that if you have anything of this form, so if you have for all x in some domain, or just for all x, if p of x, q of x, P of A for a particular instance A, therefore Q of A. That sort of follows that modus ponens. And you might remember this from section 1, where we have P implies Q, P, therefore Q. All right, so you might remember that was modus ponens. And universal modus tollens suggests that if you have a conditional statement, let's say P implies Q, remember not Q, therefore not P. That was our universal modus tollens. And so we're hoping that if we have some sort of form that fits one of those two, we can determine if we have a valid or an invalid argument form. And so it's kind of a throwback to what we just did not too long ago. So I want to show you several examples of how we're going to implement something like this. So we want to rewrite the arguments using symbols and determine if we have a valid or an invalid argument. So the first one we have is a number is negative, then its cube is negative. X is a particular negative number, therefore X is negative. Now, this is different because this is going to not necessarily say we have a specific value. All right, so remember before, we didn't necessarily have specifics in there. So now we have particular instances. And so here's what we're going to do. Let's define P of X to be X is a negative number. And let's define Q of X to be X cubed is a negative number. And so what you can see is a number is negative, the cube is negative. So X cubed is a negative number. And because now we've defined that, now we can go through and let's just define X to be some particular number. Okay, so X is a real number, or in fact, we can just say X is an element of the real numbers. That way we don't have to use the equal. X is an element of real. And so here's what we can do. We could say this is P of X and this is Q of X. All right, so we have P of X implies Q of X. X is a particular negative number, so that would be P of X. X is a negative number, and therefore X cubed is negative, therefore Q of X. And what we would say is that given all of this, this is valid by universal modus ponens. All right. Now we have to make sure that we have all of these definitions before we go through and do anything else. A second example, if a polyhedron has 4 sides, then the sum of the angles must be 360, and let's just say 360 degrees, and this is a degree as well. If the sum of the angles of a particular polyhedron S is 360 degrees, therefore S has 4 sides. So let's call it P of X, and let's say X has 4 sides. All right, so, and we would just assume that if it has 4 sides, it's going to be a polyhedron. Let's call Q of X defined as the sum of the angles must be 360. So the sum of the angles of X is 360. Okay. Now, the other thing that we have to do is we have to define S to be a particular polyhedron. So S equals a polyhedron. Right? So now what we're going to do is we're going to go through and we're going to build the logical statement. So we have if a polyhedron has 4 sides, so we're going to have P of X implies Q of X. All right. And we're going to say that the sum of the angles of a particular polyhedron is S is 360. So that means the sum of the angles must be 360, which is Q of X, but that's Q of S, all right, because we're talking about a particular polyhedron S, and therefore we could say that S has 4 sides, so we could just replace that with S has 4 sides. So we have P of S, therefore. Now this is clearly false. Okay, so this is invalid. And you might remember if you flip Q and P, that's not necessarily true. That's called a converse error. Right? That's the converse when you flip P and Q in a conditional statement. So this is invalid by converse error. A third example, all insects are small, dogs are not small, therefore dogs are not insects. Define P of X. P of X is going to be X is an insect. Right. And let me erase that, make it look like the word insect. All right. Q of X, X is small. Right. And let's say X is an element of dogs. All right. Because those are the 3 things that are really going on. We have insects, we have things that are small, and we have dogs. And so what we can say is that all insects are small. So that means if X is an insect, then X is small. So P of X implies Q of X. Then dogs are not small. So not Q of X. All right, so X is not small, right? So we're looking at this and we're saying Q, not Q of X. And then therefore, dogs are not insects. So X is insect, X is in dog, so we can say not P of X, right? And I believe that's going to follow our universal modus tollens. So we go back up here, it follows exactly the form of our universal modus tollens. So this is valid by universal modus tollens. All right, and one more example. All rational numbers are real numbers. 2i plus 5 is rational. 2i plus 5 is not real. So let's define P of X is that, let's say X is a rational number. So X is in Q because we have a rational number. Let's define Q of X to be the predicate X is a real number. Right? And let's define, let's say, I don't know, let's define B to be 2i plus 5, right? Because that's our specific instance. And so if we want to build this, we can say P of X, so all rational numbers are real, which means that if a number is rational, then it is real. So P of X implies Q of X. Then 2i plus 5 is rational, right? So that basically means that right here, so we're going to have Q of B, or I'm sorry, P of B. And then therefore, 2i plus 5 is not real. And since we defined Q to be real number, we can say not Q of B. All right. Now, clearly this is not valid because it doesn't fit either of the forms of universal modus tollens or universal modus ponens. But what we can say is that it's invalid. Okay, so let's just call it invalid. All right. If you want to say that it doesn't fit either a converse error or an inverse error, that's fine as well. All right. So in the last section of this chapter, what we're going to do is we're going to take a look at how we're going to go through and do the exact same thing, but we're going to use Venn diagrams in the next section.